Okay, we are going to talk about how to find the center of mass of what the book refers to as a planar lamina, which, and they show a picture of this, and in geometry you talked about something called a centroid. Like if you had a triangle, if you cut a triangle out of a piece of paper, and you had this triangle, and the centroid of a triangle is 2/3 of each of these. It's actually right here. But let's say you took that triangular piece of paper and you tried to balance it on the tip of a pencil, that would be your centroid or your center of mass right there. And we're going to look at how to find that for different shapes, not just a triangle, all sorts of functions. So this will involve calculus, where yesterday did not. The first thing that we need to talk about is that um, mass of a planar, whoops, mass of a planar or of a plane. So basically you have, two functions like we've had. So we'll say here's f and here's g. To find the mass, if I would give this some sort of mass, this plane, it's equal to the density times the area. And so the key word for us there is area, because we know how to find the area between f and g. That'll be an integral. So we're going to integrate that. The density, um, we don't know that, and that's just going to be an unknown. And they let it equal rho in the book, which is a Greek letter that kind of looks like a P, if I remember right. So we'll just call this, it's spelled rho like this. So we're just going to let the density equal rho, because that's really not going to come into play. It's actually going to cancel out when we find the center of mass. So before we do anything else, let's write an integration. Because we are finding area, and because we don't want to just do a summation, to find the mass, m, we would integrate from a to b of rho, which is a constant, times f of x minus g of x, and then d of x. So that's just a basic integration to find mass. It's just the area times this little value of the density that we don't know, that we're just going to call rho. So that's the mass. But remember, when we worked with one dimension and two dimension, we had the moment about x divided by mass, and we also had the moment about y divided by mass, and this was our x value, and then this one was our y value. So to get the x center of mass for the x value is my over m, and the y value is mx over m, and we talked about, because it's the distance, we talked about that yesterday. So this is where it gets a little bit tricky, and we'll see how my drawing works here. I'm going to pick a rectangle just like we've done in the past with other things. I'm going to put this rectangle in here. I'm going to put my x and y axis in here. And then I'm going to pick a point which I'm going to guess is the centroid, or the center of mass, right here. And I'm sure my guess is way off, but I'm going to put it there. And I'm going to call this point the center of mass, and we're just going to call it x sub I, comma, y sub I, because that's my center of mass. So if you think about this, your moment about the x, let's start with that. Moment about the x is going to be right here. So it's going to be right here, and here's the x-axis, so the moment about the x is going to be this distance, okay? And if you think about that, this distance from x, or however you want to say that, this is basically the midpoint of this rectangle. So the moment about the x is going to involve the midpoint of that rectangle. Well, the midpoint of that rectangle, though, when I say that, it's going to be a y value, right? Because it's about the x. So it would be the f function, the evaluated at f, plus the g function value divided by 2, because it's a midpoint. So it goes from here to here. It's the midpoint between f and g, and that's how I'd write that. Well, just like with any other area problem that we're doing, instead of doing that a whole bunch of times with summations, we can write this as an integral. It'd be the integral from a to b of rho times the midpoint, basically, so f of x plus g of x divided by 2 times the area, f of x minus g of x. Because we need the area, this is now a rectangle, right? So that's why we have to put that area in, because we'd be adding up all those rectangles. So rho is your density times the area, and then evaluated at that midpoint. And that's how you'd get your moment about the x-axis. Because remember, your moment is a mass times a distance. So the mass, which was density times area, and then this is your distance. So density, area, distance. So then your moment about the y-axis is going to be density times area, because a moment is the mass times the distance. So maybe if I write it this way, the rho times f of x minus g of x. So that's your mass. Now you need your distance. What is the distance from the y-axis? It'd be right here. What is that distance? That distance is x. So the moment about the y-axis would be your mass, so density times area times the distance from the y, so there. The distance from the y is x. Your moment about the x-axis would be your density times your area times your distance from x, which would be the midpoint between those two functions. And then to actually find your ordered pair where the centroid or the center of mass is located, that would be your x bar, y bar. And to find those, you take your moments and divide by the total mass, which is found by this integral. So basically for each problem, you have 3 integrals. So let's just look at a function real quick, and then we probably won't solve the integrals, but because I know you can solve them. So y equals 1/2 x squared, and y equals 0, and x equals 2, and we want to find the center of mass. So we want x and y, the center of mass. And remember, x is moment of about y divided by mass, and y is the moment about x divided by mass. So I graph these because I have to. When x is 2, y would also be 2. And so this is a parabola that kind of looks like this. And it was in between these, so the area that I'm looking at, I'm going to shade here, is this little shape there. So in order to set this up, first thing I do is I find the mass. And so the mass would go from 0 to 2, 0 to 2 of rho times the first function, f of x, which would be 1/2 x squared, minus the second function, which was y equals 0, so this one's easy. And then you would integrate that, and I would just move rho in front, 0 to 2. Actually, I'd put rho over 2 in front, because that 1/2 of x squared. And if you integrate that, I believe, I don't know what you get. So then if you do, well, let's just integrate real quick. X cubed over 3 times rho over 2. If I put 0 in there, I get 0. If I put 2 in there, I get 8 over 6, which is 4 over 3 times rho. 4 rho over 3. Okay, so then to get your moment about, let's do the moment about x, you would go from 0 to 2, so you have your area, and then you'd have your density times your area, which we already figured out the area is just 1/2 x squared, times your distance, which would be the midpoint of that. So my distance from the x-axis is the midpoint, so it would be 1/2 x squared divided by 2. And then you would integrate that. I would move all that out front. You'd have 0 to 2, you have rho here. This would become 1/4, right? And a half, so that'd be over 8. x to the fourth dx. And so you'd get x to the fifth over 5 times rho over 8. And if you put in 2 to 0, 0 is going to be 0. So you get 32 over 5 times rho over 8, which is 4 rho over 5. And then you do your moment about the y, which is going to be your density times your area times the distance from the y-axis to that rectangle you drew, which was x. So this one I would integrate rho over 2 from 0 to 2 of x cubed, which would give me x to the fourth over 4 times rho over 2 from 0 to 2, which is going to give me 16 over 8, or just 2 rho. And then to get your actual center of mass for the x, you would take 2 rho divided by the mass, which now I've already forgotten. It's been so long since we did that one. 4 thirds rho. So then I divide by 4 rho over 3. So if I multiply by 3 over 4 rho, the rows cancel and I get 3 halves, which I believe is the right answer. And then if I do the y correctly, I should get 3/5. So what that's saying is right here at 1.5 and 3/5 is my center of mass, right about there. Okay? Remind me in class to make sure we do one that we would draw the rectangle horizontally. So remind me of that. Have a good day.